Alright, here's the same kind of problem that we had before with limiting reactants. The only difference is now we're giving grams instead of moles. But it's the same routine. We have a product. We want to see how much product we can get with each of these substances. So again, I'm going to do this the mapping method way. So we have two ingredients. You're just going to treat them separately. So we want to figure out how many grams of Fe2O3 are made. So first I'm going to do the problem with Fe. I'm going to put 8.4 grams under Fe. And I'm trying to figure out how many grams of Fe2O3 I can get. And remember, we can't just go directly from grams to grams, so we're going to have to go down to moles. And once we're in moles, we'll go over to moles of Fe2O3 and then up to grams. So to do this, I need to know the molar mass of Fe, which is 55.85. So I'll convert this to moles. So for every 55.85 grams, there is 1 mole of Fe. So that makes sense. 8.4 divided by 55.85 is about 0.15 moles. Again, so if I have 8 grams, I have far less than it takes to get a full mole of iron, so 0.15. That makes sense. Now to go from moles to moles, I look at the number. So for iron, it's 4 to 2, so it's getting smaller. So I multiply by 2 over 4, that fraction, to make it smaller. So that's going to give me 0.075 moles of Fe2O3. Then I add up the molar mass of Fe2O3, which is 159.7. So there's 159.7 grams in 1 mole of Fe2O3. So I will end up multiplying by 159.7 grams for every 1 mole. So if I have 0.075 moles, that times 159.7 gives me about 11.98 grams. Okay. So I have enough iron to make 11.98 grams. So I've checked this box. Now I'm going to try the same thing with oxygen. So I'm going to just go below here. I'm going to write 8.4 grams of oxygen. And I want to get 2 grams of Fe2O3. Same deal. I can't go direct. I have to convert it to moles. And then over to moles of Fe2O3. And then up to grams. And go through that whole process again. So we'll do that. So once again, what's the molar mass of oxygen is 32. So for every 32 grams, that's 1 mole of oxygen. So if I have 8.4 grams, I do again have less than a mole of oxygen. So this is 0.263. Now I'm going moles to moles. I'm going from O2, which is 3, to this, which is 2. So I'll be multiplying by 2/3 to make that smaller. And in line with that, when I do that, I get 0.175 moles. And now I'm going to go up. Again, I'm going to multiply by the molar mass of Fe2O3. That's how many grams are in 1 mole. So times 159.7. And I get 27.95. Okay, so let's analyze what we did. We have enough iron to make 11.98 grams of Fe2O3. We have enough oxygen to make about 28 grams of Fe2O3. So clearly we're being held back by the iron. So iron is my limiting reactant. As far as how many grams of Fe2O3 are actually made, the answer is the lower number, 11.98 grams. So that's my answer. So it's pretty much just 2 problems and then comparing and seeing which one's smaller. So it's just like the gram-to-gram stoichiometry problems. If there were 2 products, you could pick either product to do the comparison, just like we did with the moles problem. That's pretty much how you go about it. So anyway, that's it. Until next time, I'm Derek Genova. Have a delightful day.